All right, thank you so much for joining us today. And in this video, we have 11 questions that we are going to go through together, different questions that is going to prepare you for your exams. So stay here with me. Let's go through all of them together with different questions. And I hope you are going to enjoy it and it's going to prepare you for your upcoming exam. Let's start. So we want to just integrate the following functions that we have here, right? So we have a lot of them, like a lot of questions here that we are going to go through together. So let's start with the first one. So the first one, we have this function that we want to integrate. So the first one, what we can do is we have integration 2x to the power 3 minus 4x dx, right? So we are saying that for us to integrate this, what we can do is, let me just go step by step for the first or two, three questions, and then we'll go straight. So when I want to do this, I can multiply the integration by this and then the integration by this. So when I do that, I'm going to have 2 out because 2 is a constant, x to the power 3 dx minus 4 out x dx. So this one here is equal to what I've written here. Now let's do the integration using the power rule, right? So this one is going to be x to the power 3. I'll add plus 1, right? So let me just do what you can see. So I'm going to add plus 1 here, and I will divide it by the 3 plus 1 that I have on the top. So I'm adding 1 to the top, right? So this one too is going to give us minus 4. This is to the power 1. So I'm going to have x 1 plus 1 divided by 1 plus 1. Then this one is indefinite integral. So I need to add plus c. Or this one is indefinite integral. So I need to add a plus c. Then this is going to give us 2x to the power 4 divided by 4 minus 4x squared divided by 2 plus c. So if I want to simplify this, I can cancel this and that. So I'm going to have x to the power 4 divided by 2 minus 2x squared plus c. So this is what I'm going to get for the first one. So I will just write the final solution here. So this is equal to x to the power 4 divided by 2 minus 2x squared plus c. So this is what I'm going to get for the first one, right? So this is what I'm going to get. Now let's look at the second one. So the second one, I'll just do it pretty straightforward. So we want to just integrate this. So I'll just maintain the 2 x to the power 3 plus 1 divided by 3 plus 1 minus 4 x. This is to the power 1. So I'm going to have 1 plus 1 divided by 1 plus 1. This one is not indefinite. This one is definite. So I don't need to add plus c. So I'm going to add this line here and put 0 to 4 on it, because this one is not what indefinite. This one is definite, like area and a curve. So I'm going to have, let's do the simplification. I'm going to have 2x to the power 4 divided by 4 minus oops, I didn't even check. I can see like it's the same as the first one that we did. Okay, let's go through it again, because I think the question here is the same as this. So it's just like we should have just taken this one away and then just put 0 and 4 here to solve it. But basically we are almost done through that. So let me just finish it up. Divided by 2 from 0 to 4, and this is going to give us 1 x to the power 4 divided by 2 minus 2x squared from 0 to 4. So you see that this one is the same as this one here. So since this one is definite, we could have just ignored the c and put 0 to 4 here from the first one and just do the evaluation. So this is what I'm going to do. I'm going to plug in the 4 inside the whole thing. So I'm going to have 4 squared divided, no, 4 to the power 4 divided by 2 minus 2 4 squared minus, then I'll plug in 0. But when I put 0 here, 0 to the power 0, 0 to the power 4 will be 0, 0 over 2 will be 0. When I plug in 0 here, this one will be 0. So this kind of 0 minus 0 here. Now, what is 4 to the power 4? So let's go 4 times 4 times 4 times 4, and we are going to have 16. So what is 4 to the power 4? 4 to the power 4 is 256 divided by 2 minus 4 squared is 16 minus 0. So what is 256 divided by 2? We are going to have 128 minus 2 times 16 is 32, and then we subtract 32 from there, then we get 96. So the final result that we are going to get for this one is 96. So you need to pay attention to the question so that you don't do the mistake that I did. See, it's the same question here, and I need to do it again before I put it inside. So this was the same as this, so I should have just put in 0 to 4 here to solve this. Yeah, so that's it. What we are going to get for the second one. Let's go through the third one. Third one, we know how to differentiate an exponential, integrate an exponential function. So we are saying that maintain the function, right, and divide it by the derivative of the top. What is the derivative of the top? The derivative of the top function is 7x. Then I'll add my constant plus c, right? So I maintain the function, then I divide it by the derivative of what is on the top. So remember, when we're doing the differentiation, we maintain the function, then you multiply it by the derivative of the top. But this one, because it's in integration, we are going to divide it by 7x when we are taking the derivative. So let's do that. We are going to have 7x divided by, now when I differentiate 7x, what am I going to get? 7, then I add plus c. So this is what I'm going to get for the c. Good. Let's look at the b. So b is basically, almost the same as the what we just did here. So the same thing. Let me just clean the solution here. So this is the c. So the b is the same thing. Maintain the function divided by the derivative of the top. So we can just do it straight. When I differentiate what is on the top, I'm going to have 4. But this one is indefinite. Sorry, this one is definite. So I'm going to have from 0 to 3. Then we plug in 3. So I'm going to have e to the power 4 times 3 divided by 4 minus e to the power 4 times 0 divided by 4. So this is going to give us e to the power 12 divided by 4 minus e to the power 0 divided by 4. E to the power 0 is 1, so I'm going to have something like e to the power 12 divided by 4 minus 1 over 4. I'll just leave the final results in this form. I'm not just going to do anything because when we are writing exam, no calculator, so we don't need to do the evaluation there. So this is what we are going to get for the D as well. Now let's look at E. So E, we said anytime you see a fraction where we have x, but x is to the power 1, then we need to think about the natural log function, right? So this is the same as integration. I can factor 3 out and have integration from 1 to 6. Then I'm going to have I'm going to have 1 over x dx, which is equal to, so we said when we integrate 1 over x, we need to get the natural log of x. So natural log of x, but we said if the values are negative, we need to put absolute, right? But since we know the limit here, upper limit and lower limit, and it is positive, we can decide not to put the absolute. So now we put from 1 to 6, and then 3, I put the 6 in, I have then 6 minus 3, then I put the 1 inside, and I have len of 1. But I know that len 1 is equal to 0, so I'm going to just have 6 minus 3 times 0, and this is going to give us ln of 6. So this is what I'm going to get for the E. All right. So this is what I'm going to get for the E. Now let's look at F. So F is like I can factor the 5 out from 1 to 2. So we said anytime this one is not 1, the degree here is not 1, we can just write this one as x to the power minus 3 dx, right? So this one, because the degree is 1, we cannot do something like that, like e to the power x to the power minus 1. So this is what we're going to get. So this is going to give us 5. So we are using the power integration or the power rule, e to the power minus 3 plus 1 divided by minus 3 plus 1 that we put from 1 to 2. Good. So this is going to give us 5 times x to the power minus 2 divided by minus 2 from 1 to 2. So I can write this one as minus 5 over 2 times x to the power minus 2 from 1 to 2. And I can write this one as minus 5 on 2 times 1 over x squared, right? Because it's to the power minus half. Sorry, minus 2. So from 1 to 2. Then now what I can do is now I can plug in the limit. So let me put them in. So this will be times 1 over 2 squared minus, so there is another minus there, so I'll open the parenthesis and I have this times 1 over 1 squared. So let's do that. We are going to have minus 5 on 2 times 1 over 4 minus, in bracket here we are going to have minus 5 on 2 times 1 over 1. So when I do that, this is going to be minus 5 on 8. Then when I multiply minus, that one's going to be plus, and then plus 5 on 2. This is the same as, now I want to make sure that the denominator is the same. We can use the first, second, third, right? So let's do that. So let's go first. So first means that this times this. So I'm going to have 2 times negative 5 is going to give us negative 10. Then second, so first, second. So I'm going to have 5 times 8 is going to give us plus, I think, 45, I think, divided by 2 times 8 is 16. So that's what you're going to get at the end of the day. Is that right? I believe 8 times 5 is, I think, supposed to be 40. Yeah. So what are we going to get? We are going to have 30 divided by 16, and you can just divide 3. This 2 goes here 15 and goes here 5. No, goes here 6. I believe 3 can go to this one 5 and go here 2. So we are going to have 5 on 2 at the end of the day. 5 on 2. Okay. So this is going to give us 5 divided by 2. Nice. Let's look at another one here. We have 1 to 8, right? So this one is like I have a plus b divided by c. This one can be written as a over c plus b over c, right? So I can do the same for this one. I can have integration from 0 to 8. Then I'm going to have 6 divided by root x minus x squared divided by root x, or dx. So this is what I can do. So I'm still doing the simplification. This one can be written as integration from 0 to 8. Now remember, the square root here can be written as 6 over x to the power 1 over 2 minus x squared x to the power 1 over 2. Still doing simplification. This is going to be from 0 to 8. This is the same as 6x to the power minus half. So I'm moving it up to become minus. When I move this one to up, I'm going to have minus. So x squared times x to the power minus half. Good. Let's do last simplification before we do the integration. So what I can do again is I can say that this is the same as integration from 0 to 8, 6 minus a half, minus. Then this one I use indices. Since the base are the same, I add the top. So I'm going to add 2 to minus half. So I'm going to have 2 minus half, and this is going to give us, I think, so 2 minus half, this is going to give us, I can multiply this one, this is over 1, so I can multiply the 1 by 2 and multiply the 2 by 2. So I'm going to have 3 divided by 2. Good. So that's what I'm going to get at the end of the day. 3 divided by 2. So x 3 divided by 2 x. So you see, we need to go through all this long process before we get the actual function that we can what do the integration with. So now we can now do the integration. So this is 6x to the power minus 1 over 2 plus 1 divided by minus 1 over 2 plus 1, then minus x 3 over 2 plus 1 divided by 3 over 2 plus 1 from 0 to 8. So what I'm going to do is, let me clean up the top solution, and then let's go up and then descend again. So now what are we going to get? We are going to have something like this. So let's go through the process. 6. Now half minus half plus 1 is going to give us half. The denominator 2 is going to give us half. Good. And then minus 3 on 2 plus 1 is going to give us 5 on 2 divided by 5 on 2 from 0 to 8. We can simplify this, and this is like you have 6 divided by 1 over 2. So this is 6 times 2 over 1, and this is going to give us 12. So we are going to have 12x to the power 1 over 2 minus this one too. We have something like 1 divided by 5 on 2. So this is 1 times 2 on 5, which is 2 on 5, right? So this is going to give us 2 on 5, x to the power 5 on 2 from 0 to 8. So now we can now plug in the 8, right? So 12 times 8 to the power half minus 2 over 5, 8, 5 minus 2. Then when I plug in the 0, basically because this one is multiplication, when I plug in 0 here, it will be 0. When I plug in 0 here, this one too is going to be 0. So I can just have 0. And this is going to give us, so basically if this one you cannot just do it, you can just leave your final answer without this in this form, right? Maybe you don't use calculators. So, but I know that 8 to the power half is kind of like, so I can write this one as 8 is the same as 2 to the power 3 times 1 over 2. Is that right? Yep. So basically, I think square root of 8 is like 2 times root 2. Yeah, something like that. Because I can write 8, this thing as like 4 times 2. Yeah, so that's true. But if you cannot do that, you can just leave it this form. So let's just leave it in this form. So we are going to have 12 1 over 2 minus 2 over 5, 8, 5 over 2. So this is what we are going to get at the end of the day. Yeah. So let's leave it in this form. So this is what you are going to get for the G. So we have done with the first one. Let's look at the question 2. The question 2, we are going to use something like integration by substitution, integration by part. So the question is, when do I see that this is integration by substitution? When do I see that I need to use integration by part? Sometimes it's kind of tricky, but we have, when you solve more questions, it actually helps you to, do the integration. Now, the first one, I'm going to use the integration by substitution. Why? Because one, I can see that the degree of this one is less than this by 1. So this is 3, this is 2. It means that when I differentiate this, the power will reduce to 2, which I can use to cancel the 2. So this is how you can see that, okay, no, I need to use integration by substitution, because when I differentiate x to the power 3, I'm going to have 3x squared. So I have x squared here, I have s squared here. So it can do the magic for me. So with the integration by substitution, we are saying that we want to change all the variables here to u. We want to change all the x to u at the end of the day. So let's see what we can do here. Now here, I'll let u to be equal to x to the power 3 plus 2. Why? Because I know that when I differentiate this here, I can cancel the 2 out. Do you see that? So this is what I'm doing. Since I'm letting this one to be equal to this, I'm going to write this one as from 0 to 2. Then I'm writing this one as x to the power 3 plus 2 to the power 4. Then I'll put the x squared dx here. So I'm going to, now I'm saying that this one is, everything under the root here is u, right? So if everything under root here is u, then see what I can do. I'm changing everything to u. So I need to make sure that I change the limit also to what? U. So this is what I'm doing. When these are the x values. So when x is 0, what am I going to get? I'm going to get u to be 2. So I plug in 0 here and I'm getting 2. When x is 2, what am I going to get? U will be equal to 2 to the power 3, which will be 8 plus. This one is going to give us 10. Good. So now the integration here is going to be from when it is 0, we get 2. 0 is giving us 2. So we are going to have 2 here. And when it is 2, we are getting 10. So we are having 10 also here. Right. Now, what can we see again? We can see that this one here is u, right? That is what is here. So I can have u to the power 4. Now, what is left for me to change is this. So I need to now find for dx, right? So let's go and do that. Since I want to do that, I'm going to differentiate u with respect to x so that I can see my dx here. Now let's do the differentiation, and we are going to have, this is going to give us 3x squared. Right. Now let's make, this is over 1. Let me multiply 1 by this and this by this. I'm going to have du to be equal to 3x squared dx. Right. Now we can see that here is x squared dx, and by here is 3x squared dx. So for us to get the x squared dx, we need to divide 2 by 3, divide 2 by 3. So when I do that, I'm going to have du over 3 is equal to x squared dx. So now we can see that this is right here, which is equal to du over 3. So this is going to be multiplied by du over 3. This is what we call integration by substitution. I was able to change all the x to what? U, including the limit. So this is integration by substitution, including the limit. Good. So now that I'm done with this, then I can simplify. I can factor the 1 over 3 out and have 2 to 10 u to the power 4 du, right? And this is going to give us 1 over 3. And when I'm integrating u to the power 4, I'll have u 4 plus 1, which is going to give us 5, and then 4 plus 1, which is also going to give us 5 from 2 to 10. Right, so let me just simplify this. So this is going to give us 5, and this is going to give us 5. Don't forget now, the limit here is for u, so we can just do the direct substitution from there, right? Because it's for u, it's not for x. So this is going to give us 1 over 3. I plug in the 10. I'm going to have 10 to the power 5 divided by 5 minus 1 over 3, 2 to the power 5 divided by 5. Good. So 1 over 3. What is 10 to the power 5 divided by 5? 10 to the power 5 is like 10 times 10 times 10 times 10 times 10. So we are going to have 100,000 divided by 5, and we are going to have, so let's just, we are just going to get something crazy. So 20,000 minus 2 to the power 5, 2 times 2 times 2 times 2 times 2, we are going to get 32. So this one is going to give us like 32 divided by 15. So we can just leave the final answer in this form, right? We don't need to all we need to do is we know how to do the integration, right? So kind of, this is like, if we are not using calculator, you can just leave it in this form. So I'm just doing it as if I'm not using calculator, right? So I get to a place where I think it needs a bit of calculation and calculator, it's going to waste my time, I don't need to just do it. I just make sure I leave it there and then I'm done. Good. So now let's look at B. B is like we need to think about integration by part. With this one, we cannot use integration by substitution because the degree here, this is 1, this is 1. So when I use integration by substitution, still I cannot change all of them to u. So the best way to do this is to use integration by part. What is integration by part? The formula goes like u the vein is equal to u vein minus vein du. Now this integration by part formula was derived from product rule. Remember, if we are doing something like this and this is like product rule, if this one is differentiation, then we need to use the product rule. I'll do when I'm doing videos on how to do the integration and those things, I'll prove using the product rule and the derivative to derive this formula here. But now we just need to memorize this, that this is the integration by part formula, right? So let's do the comparison. If I want to compare this to the question that we have here, good. Now the idea is that always choose u in a such a way that you can differentiate it to a constant term. So I have this integration here, this is going with this integration here, right? So this integration is out. So what I'm going to do first is I'm going to choose u to be equal to x. So if this integration is going to this integration and this x is going with this x, what will be left? It will be left with the v, and the v should be equal to everything left here. So it means that my v will be equal to e to the power 3x dx. So that is the idea. So whenever you are doing the comparison, this is equal to this, u is equal to x, everything left is for the v. Now when you look at the formula, we need u, but we have u, we need v. We don't have vein, so we need to look for vein. How do you look for vein? This is the vein, meaning that the function is what? Differentiated. So what we need to do is we need to integrate it. So we are going to integrate, So when I integrate this, d will cancel the integration, so I'm going to have like vein, which will be equal to, now when I'm integrating e to the power 3, we said maintain the function and divide it by the derivative of the top. So when I differentiate the top, which is 3x, I'm going to have 3. So now I have my u, I have my vein, because this is my u, this is my vein. Now when you come here, I need vein, which is here, but we need the u. Where can we find u? U is here, so we need to differentiate this function to get the u, right? So this is, I want to differentiate u with respect to x. So this is, when I differentiate x, I get 1. This implies that the u is the same as the x. So I think everything is ready for us to go. We have u, we have vein, we have du. So now let's try and then do the substitution and let's go. So this integration right here is going to be equal to u times vein, because we are saying that this is the same as this, as we did the comparison. So like we are just equating them like this. This is the same as u times vein. What is u? This is u. What is vein? This is vein. So let's do the multiplication. We are going to have x e to the power 3x divided by 3 minus here. Then we put the integration there. What is vein? This is vein right here. So we have e to the power 3x divided by 3 times, what is du? Du is equal to the x. So we are going to have the x. A lot of work. This is hard work, you know. This is a lot of work. You know, just relax. When you finish, just pick the question and try to go through the process again, and then we will see what you can get. So this is going to give us x e to the power 3x over 3. I can factor 1 over 3 out and I'll have 3x dx. We have already integrated this, right, which is right here, and we had this. Can you see that? Or you can just do it again. So x e to the power 3x over 3 minus 1 over 3. Then when I integrate this, I have e to the power 3 divided by 3 plus c, because this one is indefinite, right? So this is what I'm going to get. And if I want to do my final simplification, I'm going to have x e to the power 3x divided by 3 minus e to the power 3x divided by 9 plus c. This is a lot of hard work. I know. It's a lot, but I think it's also nice, So this is what you're going to get at the end of, everything that we are doing here. This is what you're going to get at the end of everything. Good. So basically, that's what we are going to get. Now let's look at this one too. What can we do here? This one we need to use integration by substitution. Why? Because here the degree here is 1 and we don't have any other term. So like when I differentiate this x, I'll get 1. So I can use integration by substitution. So look at how I'm going to do the integration by substitution. This is the same as 0 to 8. I can write this one as 5x plus 9, 1 over 2 dx. Then I will say let u to be equal to 5x plus 9. Right. So it means that now I need to change the limit to. So anytime you are doing integration by substitution, when you are doing it, you need to change the limit to as well. So when x is 0, what are we going to get for u? 9, right? And then when x is 8, what are we going to get for u? So now when x is 8, this 8 times 5 is 40 plus this one is going to give us 49. So it means that when we are doing integration by substitution, the lower limit is 9, upper limit is 49. Then now we are saying that this guy right here is equal to u. So we are going to have u to the power 1 over 2. Then we need to just change the x to the u because now it is in terms of u. So now what can we do? Since we have u, then we can differentiate u with respect to x. So du over dx will be equal to 5. Then let's try and make the x the subject. So I'll multiply this one by this. I'm going to have du is equal to 5 dx. Now we are just finding only dx, so we need to divide 2 by 5, divide 2 by 5. So I'm going to have du over 5 to be equal to dx. So in place of the x, we are going to replace it by du over 5. Interesting. A lot of work. Good. So now we are done with the hard work. We need to enjoy doing the integration. So this one is going to give us 1 over 5. Now from 9 to 49, u to the power 1 over 2 du. Right. Now what do we need to do again? Then basically this is like we are done with all the hard work. So like now what we need to do is just apply the rule, right? So 1 over 5, u to the power 1 over 2 plus 1 divided by 1 over 2 plus 1 from 9 to 49. So 1 over 5, this is going to give us u. When I add, I'm going to have 2 on 3 divided by 2 on 3 from 9 to 49. This is going to give us, now 1 over 5 divided by 2 on 3. When I change it to multiplication, I will change this one to something like 3 on 2. So we are going to have 3 divided by 10, u to the power 2 on 3 from 9 to 49. And the last thing that we need to do here is just do the plug in. So let me just shift this guy here and then let's plug in 49. So 3 over 10, 49 to the power 2 on 3 minus 3 on 10, 9 to the power 2 on 3. So we can just leave our final answer in this form because it's kind of, we need a lot of calculator before we can do that. So this is what you are going to get when you are doing integration by substitution for this type of question. All right, so we are done with the first page. let's move to the second page. Okay, so we are still working with that. So this one that we are doing, this one I can see it and I say that, okay, the final result for this one is like 4 out 1 over x minus 7. So we said that when it is just x, look at this, when it is just x and the degree is 1, we need to have something like ln. So this one, when I put it into brackets like this one is having a degree of 1. So I can look at this and say that this is the same as natural log of x minus 7 plus c. Somebody is asking how. Okay, so let me just simplify it for you. Let me just go back and I'll just leave it there. So what we can do is we can use something called integration by substitution, right? So let's do integration by substitution. So from here, from where I have simplified the function with the red, I can factor the 4 out and it will be left with this. So what I'm going to do is I'll say let u to be equal to x minus 7. So when I do that, what happens? The one in the red is going to have 4, 1 divided by u. Is that right? But now what we need to change is we need to change the x to the u. So I need to differentiate this with respect to x, and I'm going to have 1. This implies that the u is the same as what? The x. So the x is the same as the u, so I'm going to have du. Now let's do the integration. We said that when you have something like 1 over x and you are differentiating with respect to, you are integrating with respect to x, it's going to give us natural log of x. So this one is going to give us natural log of u plus c. But here, because it is indefinite, you remember we didn't change any limit here. So it's like the function is still in terms of x. So what we need to do is we need to look for u and come and replace it. But we know that u is equal to x minus 7. And when we do the replacement, you will see that this will be the same as that. So for natural log of, when we do the replacement, x minus 7, then we have the plus c here. Right. So we have a lot of integration skills. You know, you look at it and you do it. But the best way to go through is going through the integration by substitution. But if we're very good, then you can see that, okay, this is that. And it's not even about you being very good. It's about solving more examples and then knowing, okay, if I have this integration, this is what I'm going to do. Good. Good. A lot of work. Yes. So now let's look at the E. The E, we need to do integration by part. Yes, of course. We need to do integration by part. A lot of work. A lot of work. So we know that integration by part, we just learned the formula that in integration by part, we have u divin is equal to u vin minus integration vin du. So now here we need to choose our u carefully. Now we said that we need to choose, you know, u in a such a way that we can differentiate it to a constant term. But know that when I choose u to be this and I choose divin, this is hard for me to integrate. So here the best choice is to choose u to be equal to the natural log of x and choose. So when I take the natural log of x, what will be left? It will be left with x to the power 3 and dx. So that one is going to give me my divin, which is x to the power 3 dx. So as we went through the other time, we need to look for u, which is here, but we need to look for vin. So we need to integrate both sides. So let's do that. I integrate this. I integrate this. Now d will cancel this. So I'm going to have vin is equal to, when I integrate x to the power 3, I'm going to have x 4 divided by 4. We are adding plus 1 plus 1. This one I'm not adding the c because, you know, we are just doing integration by part. Then I need du. So since u is equal to this, I'm going to differentiate u with respect to x, and I want to differentiate the length function. What do you get? 1 over x, so that, you know, now our function will not be in terms of length again, right? So let's make du the subject. My board is so bad. So I will just multiply this by this, and I'm going to have 1 over x dx. So what will be the result for this? Now u vin. So what is u? This is u. This is vin. So I need to multiply this by this. So I'm going to have x over 4 times ln of x minus, then what do I need to do? Minus the integral of vin, which is here, du. So vin is x over 4 divided by 4 times, what is du? Du is 1 over x dx. Good. So I can clean the board because now we have all the information available to us. So when we do the substitution, this is what we're going to get. So let's simplify. This is going to give us x to the power 4 divided by 4 natural log of x minus, now you can see that one of the x will cancel one of this, so this one can be written as 1 over 4 out x to the power 3 dx, which is so nice. So the last thing that we can do here is just to integrate this. So I think we are going to have, so let me clean the top and move this one up. So we are going to have x to the power 4 divided by 4, this minus 1 over 4, and then when I integrate x to the power 3, I'm going to have x to the power 4 divided by 4 plus c. And my final simplification should be x to the power 4 over 4 natural log of x minus x to the power 4 over 16 plus c. A lot of hard work for the... Okay. So now that is the E. Let's do the F and let's jump into the next different questions, right? Because we have a lot of questions that we want to do. So now this one, I'm not going to use integration by part. I'm going to use integration by substitution, because the trick is that this guy here is like, the degree of this one is greater than this one by 1. So this is 3, this is 2. So anytime you want to do integration by part, if this is 4, this one should be 3. If this one is 2, this one should be, let me say, 1. Do you get it? So here what I'm going to do is I can write this one as integration e to the power x to the power 3 x squared dx. Then I'll let u to be equal to x to the power 3. Do you see that? Good. So if I do that, then basically this is what I'm trying to say. Then I'm trying to say that this integration here is the same as e to the power u. Can you see that? Because now x to the power 3 is the same as u. So that's what I'm going to have. So now I need to go and look for x squared dx, because we are changing everything to what? U. So if I want to do that, then I need to differentiate this function. Du over dx is equal to 3x squared. Make du the subject. Du is equal to 3x squared dx. But we have the x, the s is here. So we need to, let's look for this. So it means that we need to divide this one by 3, divide this one 2 by 3. So we are going to have du over 3 is equal to x squared dx. So this x squared dx, which is here, is the same as this. So this is going to give us du over 3. Don't worry, it is fine. It is fine. I know. It is fine. So this is going to give us 1 over 3, this du, right? And let's do the integration from here. This is going to give us something like this, 1 over 3. We said if we want to integrate this, maintain the function and divide it by the derivative of what is on the top. But the derivative of what is on the top is going to give us 1 plus the c, right? So this is going to give us 1 over 3 e to the power u plus c. But what is u? Oh, I just clean up u. We said u was equal to x to the power 3. So we just need to do the substitution. So 1 over 3 x to the power 3 plus c will be the final result for what we were looking for. Okay, so this is going to give us 1 over 3 e to the power x to the power 3 plus c. A lot of hard work. Okay, so we are done with the first and second part where we need to do integration. Now let's come to question 3, right? Now let's do some stuff. So we have this integration here that we want to, using n is equal to 3 equal sub intervals, and then we need to do the right hand end point. So we know what to do, right? So the first thing that we need to do is we need to pick our f of x. So let me just come here. We need to pick our f of x. So our f of x will be equal to x squared plus 2, which is here. Then our endpoint, what is the endpoint here? The endpoint is 1 and 10. So we need to have a is equal to 1 and a is equal to what? This. So what we are going to do is we are going to have a table which has x value, which is 1 and 10, right? And we have our f of x. So let's look for f of 1. What is f of 1? When I plug in 1 here, I'm going to have 3. And then when I plug in 10 here, I'm going to have 1, 0, I think 102. Yeah. Because 10 squared is 100, 102. So what we are doing is now, like, we want to sketch the graph. So I have my nice graph here. Now when x is 1, we have it to be 3. So let me put my 3 here. So here is where the point is going to be. Then when x is 10, put my 10 here. This is like, I think I need to continue the graph small. So this is like 102. So we are going to have 102 somewhere here. But the idea is that we need to divide this by 3. So we need to, like, the steps should be 3. So when I move 1 plus 3 should give us 4. 1 plus 3 should give us 7. And then so we are going to have it to be 1, 2, 3. So like then 7 plus 3 is going to give us 10. So it means that now we need to look for 4 and 7. So when I plug in 4 squared is 16. So this is going to give us, I think, 18. Yeah. 7 squared is 49 plus. So this is going to give us 51. So let me assume that I have my 18 here. And let me assume that I have my 51 here. So this is going to give us 18. This is going to give us 51. So kind of we are going to have something like this. Some graph that passes through all the point, right? But the first one is the right hand endpoint, right? So the right hand endpoint. Remember, the right hand endpoint, we start from the right and then we move towards the left. So this is kind of, we are going to have something like this. We are moving from here. No, right is up. So we are moving. So let me just have my graph something like this here. So I have this one here. 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 So the right is like we are moving this to this, moving this to this, and then moving this one to that. So we need to find a change. What is the change? What's the change between this and this? Remember, it is 3 because even n is equal to 3. So from here we have 3, we have 3, and then we have 3. But don't forget the coordinate here. What is the coordinate here? The coordinate here is 10. And what's 10 correspond to? 10 correspond to 102. So 102. Don't forget the coordinate here. The coordinate here is 7. What does 7 correspond to? 7 correspond to 51. So I have 51. What's the coordinate here correspond to? 4. And 4 is giving us 18. So I have my 18. Then what does the point here correspond to? 1 and 3. So the right ended will be equal to, now remember we are moving from this side. So I'll multiply the 3 by what is here, right? then multiply the 3 by what is here, then multiply the 3 by what is here. Then it gets exhausted. So I'm going to have 3 times 102 plus 3 times 51 plus 3 times 18. This is what I'm going to get. So I start from this. So the right, we start from the top and then we come down. So 3 times this, 3 times this, 3 times that. Then we are done. So when you do that, what are we going to get? So 3 times 102 is going to give us 306 plus 3 times 51 is going to give us 45 plus 3 times 18 is going to give us 54. Add everything and we are going to get 54 plus 45 plus 306 and we are having 405. So 405 is the right hand endpoint when you are doing the approximation. Now it's saying that same question, use the left hand point. So what's the left hand point? Left hand point, we move from top to down, right? So kind of we want to now move from here to this. We want to move from here to this, move from here to this, and then move from here to that. So the same point, this is 3, this is 3, this is also 3. But now we are moving from this side. So now here is going to be 3 times 3, 3 times 18, 3 times 51. So that's what we are going to have for the left-handed. So the left-handed is going to be 3 times 3 plus 3 times 18 plus 3 times 51. So what are we going to get? 3 times 3 is 9. 3 times 18 is 54. Then 3 times 51 is did we get 3 times 51 to be 45? I'm not sure. 3 times 51. Oh, that is so bad. So this one is not 41. This one should be 153. Oops, I'm sorry. So 3 times 103 is okay. And then 3 times 18. Let me just confirm. 3 times 18 should be 54. Okay, so 54 plus 153 plus 306 is equal to, so this one's supposed to be 5. This one's supposed to be 513. Oops. So 3 times 18 is giving us 54 plus 3 times 51 is giving us 153. Adding everything, so 9 plus 54 plus 153 is going to give us 216. Good. So this is what you are going to get for the A and B. Now the C is, we want us to find the exact value, right? So we just need to use a fundamental theory of calculus. So let's just do that. So we just now want to integrate it. So the one that we've done is just approximation. So now I want to just integrate from 1 to 10, x squared plus 2 dx. So let's do the integration. This is equal to x to the power 3 divided by 3 plus 2x, right? Plus 2x. So we are going to have from 1 to 10, right? So we are going to have something like this. And what are we going to get? Now let's plug in 10. 10 to the power 3 divided by 3 plus 2 times 10 minus open bracket. I plug in 1, I have 1 over 3. I plug in 1, I have 2, right? So 1 here, 1 there. So this is going to give us, I think 10 to the power 3 is going to be 1000. Yeah, 1000 divided by 3 plus 50 minus Now here is the same as 1 over 3 plus. I want this one to have a denominator by 3. So I'll multiply this one by 3, this one by 3. So I'm going to have 6 over 3. Same to this one, 1000 divided by 3. I want to make sure that this is over 1. It's having times 3. So I'll multiply this one 2 times 3. So what is let me say, what is 50 times 3? 50 times 3 should be, I think, 150. I think so. Yeah, 150 divided by 3 minus, this is going to be 7 divided by 3. And we are going to have 150 divided by 3 minus 7 over 3. So this is going to give us 1143 divided by 3. So this is what you are going to get. So like when you use the calculator to confirm, you will see that the approximation might, get close to maybe one of the approximation that we did. So when you do this one, when you divide it by 3, you are going to have 381. So like you see that it's in between the approximation that we did, right? So it's kind of, we are doing the left and then the right approximation. Right, let's go to the next question. Another integration again, but this one is kind of easy. So let me show you very quick. Now this is like question 4. Have we done question 3? Okay, we've done question 3. This is kind of question 4. And this is like they've given us information and they want us to do something like this. So we don't have integration from 0 to 11 here, but we can see that we have the one that starts from 0 and then we have the one that's up to 11, right? So go through the integration. We can see that we can split this integration into 2. We can move from 0 to 5 or from 0 to 7. But if we're moving from 0 to 5, then we need to also have integration that move from 5 to 11. But we don't have integration that move from 0 to 5 and 5 to 11. But we have integration that move from 0 to 7 and 7 to 11. So we can divide this one as integration from 0 to 7, f of x dx, plus from 7 to 15, sorry, to 11, f of x dx. So basically that's what you just need to do. So you can see that this is a continuous something from 0 to 7, then the 7 will start here. So 7 here, 7 here, and we go to 11. So when you add this one, it should give you the whole of this. So what is this integration here? This is equal to 10, and this is equal to 5. So we are going to have 10 plus 5, and this is going to give us 15. Let's do same for this. Now you see that we need something like from 5 to 16. We don't have from 5 to 16. The only one that talks about 16 is this, right? So let me write it. So the one that talks about 16 is from 0 to 16, f of x dx. But we can see that this is more than this. This is starting from 5 to 16, but this is starting from 0 to what? 15. So what we can do is we need to subtract from 0 to 5 of f of x dx. We need to subtract this one from it. Why? Because now if you do from 0 to 16, then it's like, let me just draw a line here. So you are moving from 0 to 16, but we want to just do from 5 to 16, right? So if I have this line here, if I have from 0 to 16 and I just need 5 to 16, then what do I need to do? If I pick from 0 to 16, I need to subtract from 0 to 5 from the 0 to 16 so that I can get what is here. So now what is from 0 to 16 is 3 minus, this is 6 minus 6. So this will be 3 plus 6, and this is going to give us 9. Nice. Let's look at this one. So this one is like from 0 to 16, but let's just factor 5 out, and then we have from 0 to 16 gen of x dx. So we are still using the same information that we were using here. So from 0 to 16 is here, what is 3? So we are going to have 5 times 3, and this is going to give us 15. Good. We need, this is from 0, this is from 7 to 0, right? And from, we have 0 to 7. We don't have 7 to 0. So what we can do is, one property about integration is I can interchange the 0 and 7. So instead of using this, I'm going to write this one. This one is the same as, I will interchange the 0 to 7, right? So you see what I did? I brought the 0 down and I brought the 7 up. And when I do that, I need to negate it. Yes. So I need to have negative of that. So now let's go to the information given to us. 0 to 7 is 10. So it means that when I do that, I'm going to have minus 10, because this is 10 from the information given. Then what is integration from 7 to 7? You see that this is basically 0, right? Because anytime you have integration from 0, the same limit to the same limit, remember we are going to subtract. So if the same thing, we are going to get 0. But what I can do here is I can write this one as integration from 7 to 0 f of x dx plus from 0 to 7 f of x dx, for you to see that it's 0. So now what is from 7 to 0? That's what we did here, right? And we had minus 10. So this is going to give us minus 10. Plus, what is integration from 0 to 7? It's here. 0 to 7 is 10. So this is going to give us plus 10. And we are going to get 0. So that is the idea with when we have the same limit. Let's do the last one. So the last one is like the way we did this one too, right? We are starting from 16 to 0, but we don't have 16 to 0. We have 0 to 16. So this one can be written as minus 0 to 16 gen of x dx. So this is going to give us, that one is 3. So we are going to have minus 3. Wow, kind of very fast from there. Now let's look at 5. So 5, we want to find and identify the absolute extrema, right? So with the process, first we need to differentiate, find critical values. So let's look at the 5. So the 5, this is what we are doing. Now they've given us f of x to be equal to 1 plus 6x minus x squared with a domain 0 and 5. So the domain is very important. So for us to just pick our table, remember, anytime we are doing something like the absolute extrema, we go with a table. So I have my x, I have my f of x. So I have my endpoint, but I need to go and figure out if we have a critical point which is in between this, then I add it to the table, right? So the first thing that you can do is, okay, now let's look for f of 0. When I plug 0 inside this one will be 0, this one will be 0. So this one is going to give us 1. Let's look for f of 5. Put 5 here. 1 plus 5 times 6 is 30. 5 squared is 25. So this is going to give us 6, right? Yes. So this is going to give us 6. So here, now we cannot conclude that the absolute maximum is this and the minimum is this, because we don't have the critical value. So for us to conclude, we need to find the critical value and check if the critical value is in here, then we add it to the table. If the critical value is not in, then now we can conclude using this information. So let's find the critical value. F prime of x is equal to 6 minus 2x. So what we need to do is, now we want to look for a value that when you plug it in, is going to give us 0. So basically we can just say that, okay, then let's pick 6 minus 2x to be equal to 0. And this is 6 is equal to 2x. Divide through by 2 and x will be equal to 3. So it means that when I plug in 3 here, this is going to be 0. So 3 is the critical value. But the question is 3 inside the domain here? Yes, of course. So you see that if you don't find a critical value, you might get one of them wrong because we don't know what this guy is bringing. Is this guy going to be in between this, or it will be less than this or above this? So it can be possible that even having this one, we can still have our minimum here, maximum here. So now let's find out. When s is 3, f of 3. So what will be f of 3? 1 plus 3 times 6 is 18. 3 squared is 9. So this is going to give us 10. So you see that something has changed. So now the max is now going to be here and the minimum is going to be here. So if you didn't find a critical point, then it means that you are going to lose marks. 1. You are going to lose marks for finding the derivative and finding the critical point and checking if this is inside this, right? So this is what you are going to do. So if the question asks you for absolute extrema, the question is asking you for absolute maximum and absolute what? Minimum. So now here we can conclude that absolute max is 10 at when s is equal to what? 3. If they need it in the interval form, then you can write it as 3 and 10. What is the absolute minimum? So absolute minimum is 1 at s is equal to 0. If it is interval form, you can write 0 and 1. So that is the first one. Now, first one, it was not hard for us to go through the idea of, like, let me say the critical point, right? Now let's look at 6. 6, we have the same question, but we can do it in the domain of this and in the domain of this. So let me pick the a first. So as I said, I pick my gen of x is equal to x to the power 3 plus 6x squared minus 36x plus 1. But with a, what I need to do is I have my table, like I have my x, I have my gen of x, then my endpoint is 0 and 4. So we can look for gen of 0, plug in 0, and everything goes 0. So this one is going to give us 1. Plug in 4, and 4 to the power 3 is like, what are we going to get? Like 4 times 4 times 4 times 4. We are going to have 64. So 64 plus 4 squared is 16. 16 times 6 is going to give us 96 minus 4 times 36 is going to give us 144 plus 1. So let's just do deduction. 64 plus 96 minus 144 plus 1 is going to give us 17. So gen of 4 is going to give us 17. Now we are not done. We need to figure out what the critical point before now we can conclude. So now let's find gen prime. Gen prime is 3x squared plus 12x minus 36. Anytime I have something in a form of quadratic, then I need to think about factorization, right? So let's try and factor. Now, first factorization is like, see, the coefficient of this is 3, so I can factor 3 out and I have x squared plus, what value should I multiply to 3 so that I get 12? That will be 4. Then the value that I'll multiply to 36 and get 3 and get 36 is 12. So now let's try and do factorization. So here, if you are not very good with factorization, that's when you are going to struggle. But I'll help you. Now here we have our constant function here to be 12, right? Don't think about the negative. Yes, just pick 12. So how do you find factors? We want to find two factors, and when you multiply, we are going to get the 12. But when we add or we subtract, we are going to get the 4 here. So first start with 1. So it's like 1 times what is going to give us 12? 1 times 12. So I have 1 factor here. Then you move to 2. So you see, we started from 1. But whenever you do the first one, you ask yourself, okay, 1 times this is going to give us 12. But when I add or subtract these two values, am I going to get 4? No. So it means that we need to move to the next one. So the next one will be 2. 2 times what is going to give us 12? 2 times 6. Good. You are right. So 2 times 6 is going to give us 12, right? So 2 times 6 is going to give us 12. But before we move, we ask ourselves, can we add this or subtract and get the 4? Yes. When I do 2 minus 6, I'm going to get minus 4. No, I don't need minus 4. So I can turn it and pick like 6 minus 2, and I'm going to get a 4. So this is someone that you are so confused with how to do the factorization, right? So now I'm going to use this point. So I'm going to write x squared. Now remember, we are doing x 6 minus 2 so that it gives us the 4. So how are we going to get the 4? We should get 4x. So it means that I need to add x to this, x to this. So I'm going to have plus 6x minus 2x minus 12x. Good. So 6x minus 2x is going to give us plus 4x. So this is how we can do it. Good. Now, let me show you something here. I picked the 12 here, which is here because the coefficient of this is 1. We have already factored the 3 out. If I'm doing up here, then for me to talk about the factor, I cannot pick 36. I need to multiply the 3 by the 36 before I can pick the factors. But since I've factored it out already, it helped me to reduce the factor, because if I multiply this one by this, it's going to be a whole lot. So now let's go through the process. So this is going to be 3. Now with this one, I can factor x out, and I'm going to have x plus 6. Can you see that when I factor s out? And then with this one too, I can factor negative 2 out, right? Yes, negative 2 out. And the bonus thing is that whenever you are doing a factorization and it is true, then whatever is going to be in this bracket should be the same as this. So without even thinking about when I factor 2, what is going to be left, you know that it should be left with x plus 6. Yes, and it is true. This is x plus 6, because now when I multiply negative 2 by this, I have this. Negative 2 by this, I have that. So now I'm going to have, now look at what I'm going to do. I'm going to have 3x. Now I have x plus 6, x plus 6, which is common, right? So we have negative 2 dividing this, so which is common. So I will factor it out, x plus 6 out. So now when I cancel the x plus 6 out, x plus 6 out, what will be left? So you can see clear that it will be left with, like, let me even try and clean it. What will be in the box? What will be left in the box? You can see that it is left with x minus 2. Yes. So that is the idea of when you are doing factorization here. So this is going to be left with x minus 2. This is so nice. So now here it is not hard for us to see that when s is equal to minus 6, this will be 0. And then when x is equal to 2, this 2 is going to be 0. So now minus 6 and 2 is the critical point. But now the question is, let's go and check the domain. The domain needs 0 and 4. Which one is between 0 and 4? 2. Good. So we need to pick 2, and we need to go and look for chain of 2. That is nice. So what is chain of 2? When I plug in 2 here, 2 to the power 3 is 8, plus 2 squared is 4. 4 times 6 is 24, minus 2 times 36 is 72, plus 1. So let's try and add them together. So what is 8 plus 24 is 32, minus 72 plus 1 is going to give us minus 39. Good. So now we can conclude that from here, from A, that the absolute mass, can I just write it here? Yeah. So absolute max, let me just write it in the coordinate form. Absolute max is 4 and 17, and then the absolute minimum is 2 and minus 39. Good. Good. Or you can say that the absolute maximum is 17 at x is equal to 4, as we did for this ones. Then the last one is for us to now B, we are using the same critical point because we are using the same function here, but now we are using different what? Domain. So it means that our x values will change and then our Gn of x values is going to change. So we need minus 0, 0, no, minus 10 and 0. So now what is inside the critical point now? The one which is in between minus 10 and 0 is now minus 6. So let's look for Gn of minus 10, Gn of 0, and Gn of minus 6. So with 0, I love zeros when it's kind of polynomial because it's kind of, you can see straight away that this is going to give us 1. Now let's plug in minus 10, right? So minus 10 to the power 3 is going to give us minus 1000, I think so. Yeah, minus 1000 plus minus 10 squared is 100 plus times 6 is going to give us 600 minus. So minus 10 times 36 is going to give us 360 plus 1. So minus 1000 plus 600, plus 360 plus 1 is going to give us 1961. And then let's plug in minus 6. So 6 times 6 times 6. So when I plug in minus 6, guess what I'm going to get? I'm going to have minus, this, the 1000 should be, so let me just go back again. The 1000 should be minus, yes, I think so. It should be minus 1000. So it should be 600 plus 360 plus 1 minus 1000. Good. So it should be minus 31. Good. It's good that I found out. So now let's put in the 6 now. So now when I plug in minus 6, I'm going to have minus 6. So I'm going to have 6 times 6 times 6. So this is going to give us minus this plus 6 squared is 36. 36 times 6 is 216 minus, so it will be plus because it will be 36 times 6 will be also 216 plus 1. So let's add them. 216 plus 216 plus 1 minus 216 is going to give us this. Good. So now we can conclude for the last one too that the minimum for this, so absolute max is going to be minus 6 and 217, and then the minimum is minus 10 and minus 10 and minus 39. Good. So that's what you're going to get for question 5. This video is too long, right? Good. But we are getting a lot. Let's look at question 7. We are almost done. We have like 11 questions, so we are almost done. Let's look at question 7. Now let me just start from the top. So f of h is equal to f of h x to the power 3 minus 3x plus 2, right? So the first question is we need to find h prime. So h prime will be equal to 3x squared minus 3. Is that right? So that's what we are going to get. Oops. Oh, we have question 6 here. I didn't even see that. Yeah, so question 6 is basically the same as, we've done question 6 here, so we don't need to do question 6 again. Question 6 is the same as what we had there. So basically we are doing question 7. So let me just cover it. So we are just doing question 7 because we've done question 6 already. So basically this is what you are going to get. So this is f prime, right? Then B is identify the x value for any local minimax, and then maximax, like we are finding the local maximum and local minimum. So the B, we want to find the minimum, the maximum, and then the C, we are looking for the minimum. So what we need to do is we need to find a critical point before we can do that. So let's set this one to 0, 3x squared minus. So let me just still do it here. So I'll pick 3 out, x squared minus 1. So let me continue the f prime. This is difference of two squares. So I'm going to have 3x plus 1, x minus 1. So when I get to B and I'm looking for this one, I can see that it's not difficult for me to see that the critical values is when x is equal to minus 1 and when x is equal to 1. So B is like we want to find the maximum something. So we need to pick minus 1 here and 1 here. So you need to be able to differentiate when we are talking about local max, local minimum, and absolute minimum and absolute maximum, right? So here we need to use the prime. So here we are using h prime of x. So I pick h prime of any value after before minus 1 is minus 2. In between this is kind of, I can pick 0, and here I can pick 2. So let's plug them in. When I plug minus 2 plus 1, this one will be negative, and minus 2 and this one too is going to be negative. So negative will be positive. So this one will be greater than 0. So this one is going to be positive and it will be increasing. Let's plug in 0, 0, 0. This one will be positive, this one will be negative. Positive, negative is negative. So this is kind of less than 0, negative, and this will be decreasing. Let's look at 2. 2 here will be positive, 2 here will be positive. So positive, positive will be positive. So this is positive and this will be increasing. So what will be the first one is the max. What will be the x value which is at max? So the max is the one that's giving us the maximum. So the x value here is minus 1. That is the local max. That is B. And then C is looking for the local minimum. So the local minimum is here, minus plus. So I'm going to have s is equal to 1, and this is the local minimum. Good. Now let's look at D. D is interesting. D, we just need the increasing, and the E, we need the decreasing. So you see that with this sign chart, I can do a whole lot with this sign chart. I'm going to use the same sign chart to talk about the increasing interval. So which one is increasing? Increasing here, increasing here. So what will be the increasing interval here? It's going to be from negative infinity up to negative 1, comma, and then from 1 to positive infinity. That is the increasing. E is looking for decreasing interval, and we know that the decreasing interval is between minus 1 and 1. So one question, we are doing a lot. And then we need to look at where we have concave up, concave down, and we need to look at the point of inflection. But even basically for us to look at concave up and down, we need to find the point of inflection before we can do that. How do we find point of inflection? Point of inflection is when we take the second derivative, right? So that's what you are going to do. So let me do the F, let me do the H first. But first, let me pick the derivative that we did. We had h prime of x to be equal to 3x squared minus 3. So for us to talk about f to h, we need to take the second derivative, right? So h prime prime will be equal to 6x, and then this one is like 0. So what value of x is going to make this 0? It's just when x is 0. So it's not difficult to see that when s is equal to 0 is what is going to make this one 0. So basically our H is being solved. H is, so the point of inflection is S is equal to 0. So now let's now figure out F and gene, right? So F, so let me just put F here and put gene here. So what we are going to do is here, for us to figure it out, we're going to put our point of inflection here. But don't forget, here we are using the F prime prime of X. So I need to pick any value before 0, which is 1, and pick any value after 0, which can be 2, and plug it in. So look at something here. When I plug 0, when I plug 1 inside this is positive. So this is like kind of greater than 0. So this is positive and increasing. The same when I plug in 2, I'll have this one to be greater than 0, positive, and so increasing. So here we can say that the function is not going to have concave down, but it's going to have concave up. So there will be a concave up at positive, positive, right? So this is where the concave up is going to happen. So no concave down, concave down, but concave up is happening at from minus infinity up to 0, and from 0 up to positive infinity. And it's going to depend when we are, even when we are sketching the graph, it's going to depend because we cannot even move up to negative infinity, because remember 0 here is in between minus 1 and 1, and in between that the function is also even decreasing somewhere, like kind of something, right? So that is the idea. So it's kind of going to be squeezing in between that function, right? Let's look at question 8. Question 8, you are in charge of Daniel's device. So let's try and extract the information and just do it, right? So when you are working with this question, we need to look at current and new, right? So what is the current? So the currently your company sells this unit a day at a price of this unit. So it means that the current quantity and then the current price. So current quantity is equal to 150 per day, right? And then the current price is equal to $20 per day. So this is what you're going to get. Now let's talk about new. What is new there? Now there is investigation, market research, which says that if we increase, we have determined that for each dollar you add to the price, you will sell 5 fewer. So it means that it's going to reduce those kind of things, right? So now let's define X. Okay, even X is already defined here. So X is the number of dollar you add to the original price. So now what will be the original price? Like this is the original price that we have here. So now our new price is going to be 20 plus X. So like when we increase the price by X, now what happens to the quantity? The quantity is going to go down by 3 of that price. So we are going to have the current quantity minus 5 times the new price. So that's what we are going to do. So when you increase it by just $1, like when it is 1, X is equal to 1, then it means that it's going to go down by 5. But when you increase it by 2, it's going to go down by 10 in that order. So now what we need to do is we want to form the revenue function, right? So R of X is equal to, we know that revenue is price times quantity. So this is going to give us 20 plus X times 150 minus 5X, right? So this, let's just simplify that. So write down a formula for total revenue. Yeah. So we can just talk about multiplying 20 times this one 2 times 15 is 30, so we are going to have 3000 minus 100 x minus 150. No, 1 should be plus 150x minus 5x squared, and this is going to be 3000 when we add plus 50x minus 5x squared. So this is what's going to be our revenue function. Do you have any other question addition to this? No. So this will be the question 8. So this kind of question, try and figure out current, old, and then put your information together. Now let's look at question 9. You are selling a product, and basically this is like they've given us the equation. We have the price here and we have the cost. Very nicely. So we want to find the revenue, and we need to find but we know that revenue, right? We know that revenue is equal to price times quantity, but we have some situation that we need to use the quantity to be X. We need to have the quantity to be also Q, right? But basically, whenever we are dealing with X and we don't have Q formula, then we need to use the quantity to be X. So price is given, which is here. So we are going to have 70 minus X times X. So this is going to give us 70x minus X squared. That will be the revenue. Find the price, the profit. So profit is equal to revenue minus cost. So what is the revenue? That's what we just did. This is the revenue. So we are going to have 70x minus X squared minus, so because I'm doing minus, I'll put it into what? Parentheses. But basically, I think this one is just one variable, so I don't need to. This is just one term. So I can just do minus 10x, and I'm going to have 60x minus X squared. So that will be my profit. Now, next question is find the value of X which maximize the revenue. So to maximize the revenue, we need to differentiate it and look for the X value that will make it 0. It means that X value, the quantity that we need to sell, that we will be at maximum. So our R is equal to 70x minus X squared. So what will be R prime? It will be 70 minus 2x. So for us to maximize, the X value should make sure that this is equal to 0. So we are going to pick 70 minus 2x and set it to 0. 70 is equal to 2x. And when you divide 2 by 2, x should be equal to 35. So the X value that is going to maximize the revenue is when X is equal to what? 35. Same thing here. We want to find X that maximizes the profit. This is the profit function. So P is equal to 60x minus X squared. So what is P prime? 60 minus 2x. We need to make sure that we find value of X. That will make sure that this is 0. So 60 is equal to 2x. Divide 2 by 2. And here your S should be 30 before we can maximize profit. Right. So that is basically question 9. Let's look at question 10. Good. So question 10 is you are trying to determine the optimal dimension for a rectangular field surrounded with fencing. So we are saying that the fencing on the north side costs $5 per foot. So let's assume that this is the north side, right? So it means that since it's $5, this is going to be 5x, right? And then the fencing on the other 3 side costs $1. So the other side. So remember, if this is y, here is supposed to be y. And basically, if this one here is x, here should be x. But we are saying that because maybe we want to do some box here, so the cost here is going to be like 5. But the rest is just 1y, 1y, 1y. So this is what we are going to get from the question. Now the question is saying that the area of the rectangular field is this. So what is the formula for finding area of a rectangle? X times y, right? So the area is xy, but area is given to be 1200, which is going to give us xy. So what we need to do is, now the question is, we want to find the dimension that minimize the cost. So the cost is the what we are going to bear, or the cost that we are going to get when we are fencing this. So the cost function is going to be adding everything here. That is the parameter, right? So you are going to have 5x plus x plus y, and this is going to give us 6x plus 2y. So that will be the cost function. Now what can we do? Here we want to make sure that our cost function is in terms of only one variable. So we can make y the subject here and plug it in here. So let's do that. This one, when I divide through by x, I'm going to have y to be equal to this. So now I'm going to plug in this here, and now my cost function will be in terms of only x. So I'm going to have 6x plus 2 times this divided by x. I'm going to have, when I multiply 2 by 12, I'm going to get 24. So I'm going to have 6x plus 24 over x. So this is my cost function that I have gotten. So now what I need to do is, now I need to find a dimension. But before we find the dimension, let's try and work with the domain. Like, let's try and find the domain of this function. So let me go up there and write this function there so that we can use the app sheet. So we saw that now our cost function is equal to 6x plus 24 divided by x. Is that right? Yeah, that's right. So let's find the domain. Now, for us to find the domain, I can write this one as 6x squared plus all divided by x, right? So I'm finding the LCM, or this is divided by 1. So if we are using our left and right, this will multiply this, which is going to give us this. 1 will multiply this, which is going to give us this, divided by 1 times x, which is here. Now I want to find the domain. So finding the domain for this, we can see that here the domain x shouldn't be 0, because as soon as x is 0, what happens? The denominator will be this. So it means that our cost function here, our x should be greater than 0. So that's one point. The other point that we can see is, we can just take the top and set it to 0. So 6x squared plus 2, this is equal to 0. So 6x squared should be equal to minus, minus, let me see, 240, divide 2 by 6, and you see that this one too, because this one is squared, there is no value of s that's going to make the top 0. So our domain will be just s is greater than 0. So that will be our domain, right? So our domain will be x should be greater than 0, because here there's no value of x that's going to make this one 0, because this one is squared. So now that's our domain. Now what we want to do is, we want to find a dimension. So what we need to do is, we need to differentiate this. That's what we want to do. So now let's do the differentiation. Now c prime of x, we are going to use what is called we are going to use the domain is x greater. We are going to use quotient rule, which we have u over that. So u is equal to x squared plus this, and vin is x. What is u prime? U prime is 12x, and what is vin prime? This is 1. So we know that our integration should be vin, if we are using the quotient rule, vin u prime minus u vin prime divided by vin squared. So what is vin? Vin is x times 12x minus u is x squared plus this in bracket times vin prime is 1 divided by v squared. Simplify, and we are going to have 12x squared minus 6x squared minus 2400 divided by x squared. So now we need to look for values that is going to make the function 0. Now we said that our denominator cannot be 0. So the only one that can be 0 is the top, right? So let me even simplify the top. The top is going to give us 6x squared minus 2. Good. So you see that it's kind of, now the top here is like kind of what we had here. But the only thing is that this is negative and this is positive. So since this one was positive, we didn't have any value that will make this one 0. But because this is minus, we're going to have a value that will make this one 0. So let's pick the top and solve. 6x squared minus 2400 is equal to 0. 6x squared is equal to 2400. So now let's divide the top by 6. 6 times what is going to give us 24? I think 6 times 4, right? So when I divide this one by 6, I'm going to have x squared to be equal to 400. And then what is square root of 400? So square root of 400 is, let me see. Square root of 400 is like, what number that when you multiply, you are going to get 400. Let me see. 100 to the power 4. No, it's not 100 to the power 4. Kind of this root of, okay. We are picking root of 400. Root of 400 is like 20. Okay. 20. This is so hard when you are not using calculator. So this is the same as 20 to the power 2. Yeah. So yeah. Great. So now our x is 20, right? So that is the x value here. So since we've gotten the x value, we can even test if yes, this is what is going to minimize the function. We can even take the second derivative, or we can use our sign chart, right? Like sign chart like this to check if it is indeed the minimum function. So what we need to do is we can pick any value here and then we plug it inside this. So any value here can be 1. Let me just choose 1 because 1 will be so simple for me to put it inside. So 1 here is going to be 1. 1 here, 1 here. This is kind of like, because this is 1, this is going to be like negative. So you will see that this is going to be like decreasing. And then when I pick anything here, like something like 21 squared times this one is this one is going to be positive. Like this one will be greater than this. So everything here will be positive. And then you will see that this one will be increasing. So you will see that there will be a minimum here. So that is the idea. So the x value that is going to minimize this is when x is going to minimize the cost is what? S is equal to 20. But we want to look at the dimension. So we need to now find for y. But we know that y is equal to this. So now what can we do? Y is equal to this divided by 20. So we just need to divide this one by 20. And 0 will cancel this. And then 2 goes to 120, I think 60. Yes. So the dimension that is going to minimize the cost is when we have x is equal to 20 and y is equal to 60. That's what you are going to get from here. I think let's do the last 2 questions and then we are done. So this is the last 2 questions. Yeah. So let's just go through very quick and then we are done here. Now we want to find the 2 numbers x and y which maximize the product x, y with a constraint this. So this one is like kind of like if we are constructing it from function, it's like when you have a river and you have like a rectangle here and then we have like x here, and you have y here. And we are saying that fencing that is going to give us 20 and then the area is like xy, right? So that is the basically the idea here. So let's assume that the area is equal to xy. They've given us the constraint to be 2x plus y, which is equal to 20. So what you can do is, let's make y the subject. So y will be equal to 20 minus 2x. So let's plug it inside the area. This is going to be x, 20 minus 2x. So this is going to be 20x minus 2x squared. So this is the area. We want to maximize it, so we need to differentiate the area. So a prime will be equal to 20 minus 4x. Set this one to 0 because this one is not quadratic, it's just a linear function. So 4x will be equal to 20, and then x should be equal to 5. So what you can do is, we can test this, anytime you want to look at, like, okay, indeed, this is what is going to maximize. You can just use the sign chart, or you can use the second derivative, right? So when I plug in, like, I pick any value here, I can pick something like 4. 4 times 4 is going to give us 16, and this is going to be positive, so this is going to increase. When I pick 6 here, 6 times this one is going to be 24, and this is going to decrease. So you will see that we are having it like this. So it maximizes it like when x is equal to 5. Good. So what are we looking for? We are looking for the two values, x and y. So now we need to find y. Good. Y is equal to this. So 20 minus, what is x? X is 5. So 2 times 5 and 2, and this is going to give us this. So the x and y value that is going to maximize the product is x is equal to 5 and y is equal to 10. Yes, indeed. That's what we are going to get. Now, last one, then we are done with this review question. Is now we want to look at the global extrema. Now, when we talk about global extrema, basically, like, we are talking about like absolute extrema, like kind of, that's what you need to have it in mind. So what can I do here? Like, I'm going to have y, which is equal to x squared plus 16 divided by x. I think that's the right question. Yeah. And the domain here is 0 and infinity. So you remember that whenever we are doing absolute extrema, the domain should be like something like this, with a squared something like this, so that we can test the domain. So here, the idea is that the domain is not inclusive, right? So we think about global extrema, think about we are doing absolute maximum. So we need to find the endpoint, like we need to plug the endpoint inside this. But the idea is that the endpoint is open, so kind of so difficult, but we will check that. But so here, what is important here is for us to find a critical point. So what can we do? Y can be written as x to the power 3 plus 16 divided by x. Can you see that? So this is over 1. So left, right, that. So we are having this. So let's find this using the quotient rule. This is going to give us, so y prime should be u prime vin, or vin, u prime minus u vin prime divided by vin squared. So what is u? U is x to the power 3 plus 16. And this is going to give us, u prime is going to give us 3x squared. Vin is x and vin prime is 1. Let's find y prime. So vin is x times u prime, which is 3x squared, minus u is x3 plus 16 times 1 divided by x squared. Multiply that and we are going to have 3x cubed minus x cubed minus 16 divided by x squared, and this is like 2x cubed minus 16 divided by x squared. Good. So anytime you have something like this, if we are looking for the critical values, yes, the critical values, we look at the ones that it make the function undefined. Yes, definitely when x is equal to 0, it's also a critical value. But basically, if we have 0, we will see that maybe 0 is actually 1 on the bound here. So we need to just don't think about. What we need to think about is we need to think about making sure that the top is equal to 0. So I set this one to 0. 2 is equal to 16. Divide 2 by 2 and you get 8. And then this is the same as 2 to the power 3. So since the top are the same, the denominator should be the same. So x should be equal to 2, right? So s is equal to 2. We need to look for something here. So we said that with absolute, this one, we actually need a table with our x values, right? So here we have, is it f of x, y. So let me just say that y is f of x. So I have 0, I have infinity, I have my, my point here. So when I plug in 2 in f of x, what am I going to get? I'll show you something. Let's plug in 2 here. Here will be 4. Plug in 2 here. This will be plus 8. And it's going to give us 12. So this is 12. But let's look at 0. When you plug in 0. When I plug in 0 here, this is going to give me 0 plus 16 over 0 is infinity. So this is kind of infinity, right? So this is we are going to get infinity. Then when I plug in infinity here, this is also going to give us like infinity. Then like infinity divided by 16 divided by infinity will be 0, and this one too is giving us infinity. So infinity. So like this is infinity, like this one is like 12. So actually we don't know whether this 2 and 12 here is a maximum or minimum, because we don't actually know these people, right? We don't know. So we don't know whether this is like a minimum function or a maximum function. So what we can do is we can either use the second derivative test, or we can use the lines as the sign chart to determine if this is going to be the minimum or it's going to be the maximum, right? So that's what we can also do. But if we have the values there, then we don't worry ourselves checking it. So let me put 12 here. Now let me pick anything here. No, anything here, I can decide to pick 1, because 1 is very important. Like 1, when I plug 1 inside the derivative, it's is going to simplify the thing for me to see that, oh, this is simple. So plugging 1 here, this one will be 1. When I plug in 1 here, definitely it will be 2 minus 16, and it's negative, right? So it's like this is negative and this is decreasing. Then I pick any value here. I can pick 13. Now you can see that 13 to the power 3 times 2 will be bigger than this. So this minus this will be positive, and this one too will be positive. So this one is going to be positive. So this is like positive and this is going up. So basically now we can see that this is going to take a concave up shape, which means that it's going to be the minimum. So here we can say that the global minimum is 12 at s is equal to 2, or we can say 2 and 12. So we can see that here we don't have, there is no global maximum, because they are all giving us infinity on the bound, right? So we don't have any global maximum. Yeah, so this is the end of the video, and guess what? I have another discussion sheet that I'm going to release maybe in the next day. So go through this, and I release that discussion sheet. Then I'm going to, after that discussion sheet, I'm going to also release another video on the spring exams 2024 full video for you to see how the questions are being set, and what is expected from you. All right, I hope you enjoyed the video. I hope you stayed here to go through all this video. I hope you find it useful. Now see you in the next